NASA has made remarkable advancements in space exploration over the years, with countless achievements that have reshaped our understanding of the universe. Among these innovations, one recent breakthrough stands out as a game-changer: the Dream Chaser spacecraft. Developed by Sierra Nevada Corporation (SNC), the Dream Chaser has the potential to revolutionize space travel with its innovative design, reusability, and versatility. By offering a more cost-effective and sustainable method of space transportation, Dream Chaser could transform how we approach both cargo and crewed space missions. The birth of Dream Chaser. The Dream Chaser spacecraft emerged as part of NASA's strategy to leverage commercial partnerships to meet the growing needs of space transportation. Following the retirement of the Space Shuttle program in 2011, NASA sought alternative vehicles to maintain a presence in low Earth orbit (LEO), as well as to provide a reliable means of resupplying the International Space Station (ISS). As part of NASA's commercial crew and cargo programs, the agency engaged private companies to develop spacecraft capable of ferrying cargo and, eventually, astronauts to the ISS. In 2016, SNC's Dream Chaser was selected by NASA under the Commercial Resupply Services (CRS) contract, a critical component of the effort to resupply the ISS. This was a major milestone, positioning Dream Chaser as one of the key players in the future of space logistics. As a competitor to SpaceX's Dragon capsule and Northrop Grumman's Cygnus spacecraft, Dream Chaser promised new capabilities that set it apart. Unlike its competitors, Dream Chaser features a unique spaceplane design that combines elements of both aircraft and spacecraft, offering capabilities no other vehicle currently provides. A revolutionary design. What makes Dream Chaser so innovative is its ability to land on conventional runways. Unlike SpaceX's Dragon or Cygnus, which rely on splashdowns or controlled burns to re-enter the atmosphere, Dream Chaser has been designed to glide gracefully to a runway after completing its mission. This ability provides several advantages, including smoother recovery and refurbishment processes. By landing on solid ground, the spacecraft can be retrieved much more easily and quickly, reducing operational costs and time between flights. Dream Chaser's aerodynamic design also draws from the legacy of NASA's Space Shuttle, which was a lifting body vehicle capable of re-entering Earth's atmosphere and gliding to a runway. However, Dream Chaser is smaller, lighter, and more optimized for commercial and scientific missions. It is 30 feet long and 22 feet wide, with a robust thermal protection system capable of withstanding the intense heat of re-entry. Its lifting body design enables the spacecraft to have excellent stability and control during re-entry and landing, ensuring safe returns to Earth. The spacecraft is designed with both pressurized and unpressurized cargo compartments, allowing it to carry a wide range of supplies, tools, and equipment to the ISS. In total, it can transport up to 500 kilograms 100 pounds of cargo, making it one of the most versatile spacecraft in operation today. Dream Chaser's role in NASA's future. NASA's decision to partner with private companies like SNC is central to the agency's broader goal of commercializing space. Dream Chaser is not just a cargo delivery vehicle. It is part of a larger vision for future space exploration that includes sustainable infrastructure and greater reliance on reusable spacecraft. Dream Chaser's development is a key piece of NASA's plan to foster a thriving space economy, with both governmental and private sector players working together to lower the cost of space missions and increase the frequency of launches. As part of the Commercial Resupply Services program, Dream Chaser's primary mission is to deliver cargo to the ISS. In this role, it will provide much-needed supplies, including scientific experiments, food, and equipment for astronauts aboard the station. Dream Chaser's ability to transport both pressurized and unpressurized cargo allows for maximum versatility, which is vital for the ongoing operations of the ISS. Furthermore, the spacecraft's reusability allows it to make multiple trips to space, unlike other vehicles that must be entirely rebuilt after each mission. This is an essential factor in reducing the overall cost of space missions and making space travel more sustainable in the long term. In a sense, Dream Chaser exemplifies NASA's shift towards reusable spacecraft, a trend that could ultimately lower the barrier for entry to space and make it more accessible to private companies, international space agencies, and other stakeholders, a step towards crewed space missions. While Dream Chaser was initially designed for cargo missions, SNC is working towards developing a crewed version of the spacecraft, opening up the potential for human spaceflight in the near future. This version would be equipped with all necessary life support systems and safety features to carry astronauts to the ISS and potentially beyond. This aligns with NASA's broader strategy to rely on commercial partners to provide transportation for crew members to low Earth orbit, allowing the agency to focus its resources on deep space exploration and ambitious missions such as Artemis, which aims to return astronauts to the Moon. The crewed version of Dream Chaser could play a pivotal role in reducing NASA's dependence on other spacecraft, such as SpaceX's Crew Dragon, and contribute to a more robust, multi-provider spaceflight ecosystem. The capability to transport astronauts could also help foster the growth of commercial space tourism, a market that is already beginning to see increasing interest from private companies like SpaceX, Blue Origin, and Virgin Galactic. The road ahead. Looking ahead, Dream Chaser is positioned to become an integral part of space transportation infrastructure. Its versatile design, reusability, and proven performance make it an ideal candidate for frequent resupply missions to the ISS, as well as other future missions in low Earth orbit and beyond. SNC has already announced plans to continue advancing Dream Chaser, with a focus on its potential for crewed missions and expanding its operational capacity. As NASA continues to push the boundaries of space exploration, Dream Chaser could serve as a key enabler of these goals. Its ability to land on runways, carry large payloads, and operate in a reusable, cost-effective manner makes it an essential piece of the puzzle. Moreover, successful operation will pave the way for other commercial players to enter the market, driving innovation and lowering the costs of space access for all. In the long term, Dream Chaser's development aligns with NASA's ambitions to establish a sustainable human presence in space, including plans for lunar exploration through the Artemis program. As the Dream Chaser spacecraft continues to evolve, it could play a significant role in NASA's efforts to enable long-duration human missions beyond Earth's orbit, including crewed missions to Mars. Dream Chaser is more than just a spacecraft. It is a symbol of the changing landscape of space exploration. With its innovative design, reusability, and potential for both cargo and crewed missions, Dream Chaser represents a critical leap forward in making space travel more sustainable, cost-effective, and accessible. The spacecraft's future, alongside NASA's commitment to commercial partnerships, promises to usher in a new era of space exploration, one that could change the way we view and interact with the cosmos for generations to come.